So next topic is smart objects. So smart objects are quite simply building blocks, as I told, for the network. Okay. IoT network, they are what transform everyday objects into a network of intelligent objects that are able to learn from and interact with their environment in a meaningful way. It cannot be stressed enough that the real power of the smart objects IoT comes from the being networked together rather than being isolated as a standalone objects. This ability to communicate over a network has multiple multiplicative effect and allows for very sophisticated correlation and interaction between the disparate smart object. For example, if you recall the smart farming sensors which are described in the previous section. If a sensor is a standalone device that simply measures the humidity of the soil, it is interesting and useful, but it is not revolutionary. If that same sensor is connected as a part of an intelligent network that is able to coordinate intelligently with actuators to trigger the irrigation system as needed based on those sensors readings, right? So we have something far more powerful extending that even further. Imagine that the coordinated sensor actuator set is intelligently interconnected with other sensors actuator sets to further coordinate fertilization, pest control, and so on. Okay, and even communicate with the intelligent backend to calculate the crop yield potential. This now starts a look like a complete system that begin to unlock the power of IoT and provides the intelligent automation we have come to expect from such a revolutionary technology. Okay, so we can say smart objects in IoT comes being networked together rather than being isolated. These objects, you can see their diagram. Smart objects, a definition we can say. Historically, the definition of a smart object has been a bit nebulous because of the different interpretation of the scheme by varying resources. To add to the overall confusion, the term smart object sometimes semantic differences. It is often used interchangeably with the terms such as smart sensors. There with the different names: smart devices, IoT devices, intelligent devices, things, smart things. Okay, intelligent node, intelligent thing, EKBS thing, and intelligent product. So with the different names, we are going to designate those in order to clarify some of this confusion. We provide here the definition of the smart object as we use it in this book. A smart object is described throughout this subject is a device that has at a minimum of the following four defining characteristics. One is the processing unit, second one is the sensors and or actuators and communication devices and the power source. Okay, these are the different characteristics of the different characteristics of the smart objects. So you can see here the diagram. Okay, so which contains power source, communication devices, actuators, sensors, and tiny low cost computer. It has tiny low cost computer, we call it as a processing unit, we call that is embedded into the objects to make items smart, can be organized into networks. Okay, so processing unit, what we define is a, it has a some part which is going to acquiring the data, processing and analyzing, sensing the information received by the sensors, coordinating the control signals to any actuators, and controlling a variety of functions on the smart objects, including the communication and power system. The specific type of the processing unit that is used can vary greatly depending upon the specific processing needs of different applications. The most common is a microcontroller because of its small form factor, flexibility, programming simplicity, equity, low power consumption, and low cost. When you come take a sensors or actuators, a smart object is capable of interacting with the physical world through sensors and actuators. As described in the previous sections, a sensor learns and measures its environment, whereas an actuator is able to produce some changes to the physical world. That means sensor senses, measures the sensors, and it sends to the actuators. In turn, actuators are capable of performing a task by changing the whatever the action it is need to take in the physical world. A smart object does not need to contain both sensors and actuators. In fact, smart objects contain one or multiple sensors or actuators depending upon the what kind of applications for what purpose we are using. When you come to the communication devices, they receive the instructions, sends or the routes the data self or into the self-organizing networks. The name itself is says communication device. The communication unit is responsible for connecting a smart object with other smart objects and the outside world via the network. Communication devices for smart objects can be either wired or wireless. Overwhelmingly, in IoT networks, smart objects are wirelessly interconnect for the number of reasons, including cost, limited infrastructure availability, and ease of deployment. There are myriad different communication protocols for smart objects. In fact, this is dedicated to how smart objects can able to communicate within the IoT network, especially when we go for the smart connecting the smart objects. Okay, IP as a IoT network layer. Okay, application protocols for IoT. A high level overview and refers to those other more detailed and the power sources. Smart objects have components. You take the power source. See there. So this is a power source is a smart object have components that records to be powered. Interestingly, the most significant power consumption usually comes from the communication unit of smart object as with other three smart objects building blocks. The power requirements also vary greatly from application to application because some power they are going to take a external power and some devices smart objects they are going to use an inbuilt power source itself. Okay, so that is why this power requirements also greatly varies from one application to. Typically, smart objects are limited in power, are deployed for a very long time, and are easily accessible. This combination, especially when the smart object relies on battery power, implies that power efficiency, judicious power management, sleep modes, ultra low power consumption hardware, and so on are critical design elements for long term deployments where smart objects are for all practical purposes inaccessible. Power is commonly obtained from scavenger sources, solar, piezoelectric, and so on, and is obtained by hydrolyzed manner, also tapping into the infrastructure power. So that is about the different devices that we are going to use in the smart objects. Then come for the trends in smart objects. That is the trends as this definition reveals that it perhaps the variability that is the key characteristics of the smart objects. They vary widely in function, in their technical requirements, form factor, deployment conditions, and different actions, and so on. So nevertheless, there are certain important macro trends that we can infer from recent and planned future smart object deployments. Of course, these do not apply to all smart objects because there will always be application depends variability. But these are broad generalization and trends impacting IoT. Some smart objects, the different, there will be a different trends. Size decreasing, power consumption is decreasing, processing power is increasing, communication capabilities are improving, communication is being increasingly standardized. These are the very important trends in the smart objects. When you take a size decreasing, some as we have discussed in the reference with the MEMS, there is a clear trend of your decreasing size. It is a which can be embedded in a particular device, right? So some smart objects are so small they are not even visible to the naked eye. Okay, this reduced size makes smart objects easier to embed in everyday devices. When you come to decrease the power consumption, as I told that power consumption, we can use an external power supply or inbuilt power supply, right? So we have to decrease the power consumption. The different hardware components of the smart object continually consume less power. This is especially true for sensors, many of which are completely passive. Some battery powered sensors last 10 or more years without battery replacement. Okay. As I told, external usage of the power supply and internal usage of the power supply. And when you come to the processing power is increasing. So as the data increases, okay, so processors are continually getting more powerful and smaller. This is a key advancement for smart object as they become increasingly complex and connected. Okay, because when the data what the sensors are going to produce is increases, right? So when you have lot of data, the processing power should be increased. Okay, next come for the next trend is communication capabilities are improving. Okay, so wireless speed are continually increasing, but they are also increasing in range. So it is no big surprise that wireless speed are continuing increasing, but they're also increasing in range. The Internet of Things is driving and development of more and more specialized communications protocols covering a greater diversity of the use cases and the environment. It increases the communication. It may be the speed, how fast the devices are going to communicate with each other. Whether it is a wired network, what is it a wireless networks, we are also increasing the range of this wireless network. Okay. The next trend is communication being is increasingly standardized. We have to make the standard of the communication. Why? Because so there is a strong push in the industry to develop open standards for IoT communication protocols. In addition, in addition, there is a strong push. In addition, there are more and more open source efforts to advance IoT. Okay. So these trends in smart objects begins to paint a picture of increasingly sophisticated devices that are able to perform increasingly complex tasks with greater efficiency. A key enabler of this paradigm is improved communication between the interconnected smart objects within a system and between that system and external entities. For example, we use external entities or the edge compute, cloud computing. The power of IoT is truly unlocked when a smart objects are networked together in a sensor or actuator networks. Okay, so this is about the smart objects, that is the and their trends. What are the trends? Trends is nothing but the important characteristics that we want to implement, improve the quality of this smart objects in the IoT network. The size decreasing, power consumption is decreasing. Okay, then improve the quality of the communication. Okay, and your processing power should be increasing. And the lots of data we are going to receive, we want to increase the power of that, and we have to increase the communication capabilities by using the long range of wireless networks, and we have to make the standardization of this communication. Okay, these are the different smart object trends that we need to improve the IoT network. Okay, because so in day to day we are going to use this IoT network. We want to increase the speed. We want to increase the processing power, right? So this is all about the smart objects. Okay, and come for the sensor networks. So very important, because so when we are going to study the IoT, Internet of Things, it is mainly based on the sensors. So in the sensors network, we are going to study the wireless sensor networks. And second one is what are the communication protocols that we are going to use for this wireless sensor network. Okay. So we can say a sensor or actuator network, that is a SUNET, as the name suggests, it is a network of sensors and sense and measure their environment, and actuators that act on their environment. The sensors under actuator SUNET are capable of communicating, cooperating in a productive manner. In a because of a productive manner. So, effective and well coordinated communication and cooperation is a prominent challenge for the sensor networks. Primarily because the sensors and actuators in the SUNET are diverse, heterogeneous, and resource constrained. SUNET offers highly coordinated sensing and actuation capabilities. Smart homes are a type of SUNET that displays this coordination between the distributed sensors and the actuators. For example, if you take, so smart homes can have temperature sensors that are strategically networked with the heating, ventilation, and air condition actuators. When a sensor detects a specified temperature, this can trigger an actuator to take action and heat or cool the homes as needed. While such networks can theoretically be connected in a wired or wireless fashion, the fact that SUNET are typically found in the real world means that they need to extreme level of deployment complexity. For example, smart home temperature sensors need to be expertly located in a strategic location throughout the home, including at the ventilation, air condition, and heating entry and exit points. Some of the advantages of this are, so there will be a greater deployment flexibility, especially in extreme environments or hard to reach places. And second point is there very simpler scaling to large number of nodes and lower implementation cost, easier long-term maintenance. Next point is effortless introduction of new sensor actuator nodes. without any difficulty we can adopt the new sensors and actuators in a particular node and better equipped to handle dynamic and rapid topology changes. Okay, so they're equipped with the, so we can handle dynamically rapid topologies. These are the different advantages of these sensor networks. So that is the where there are some advantages, there will be some disadvantages also. Disadvantages are potentially less secure, for example, hijacked access points. Second is typically low power transmission speeds. Okay, because of the wireless, they have the low power transmission speeds and greater levels on impact influenced by environment. Not only does wireless allows much greater flexibility, but it is also increasingly inexpensive and reliable technology across very wide spectrum of conditions, even extremely harsh ones. These characteristics are the key reasons for the wireless sonnets and the ubiquitous networking technology for Internet of Things. From a terminology perspective, that is the wireless sonnets are typically referred to as wireless sensors and actuator networks, that is a WCNS. Because of many IoT deployments are overwhelmed sensors, right? WSNS are also often interchangeably referred to as wireless sensor networks, WSNs. We commonly refer to WSANS as WSN, wireless sensor networks, with understanding that actuators are often part of the wireless network. They're also a part of the wireless sensor networks. So we refer these sonnets, their WSANS are also referred to as the, the wireless sensor networks. Okay. So that is about the sensor networks which we have covered is sonnets.